All right, in this video I want to spend a little bit of time talking about equations, which is a way of linking certain parameters and features such as the thickness of this part to the diameter of those holes. We're going to use equations for that. So we can go to the equations tab as shown there, and as we start to work through the equations, we're going to create first a global variable. And although you can't see what I'm writing there, I'll pop a screen on there that will let you see that. I'm going to have this factor called the hole factor. It's just a random name. What I'm going to do in the hole factor is I'm going to have that number relate the thickness of the part to the diameter of the hole. But in order to do that, I'm going to have to understand what the variables are called. Okay, so the diameter of the hole is called D1, as you can see right there. Now, I've turned that on. Let me show you how I turned that on. I have made the dimension names visible, and right here I just turned it off so you can see what happens when it's off. If I double click it, I'll see only the number and not a name. But if I go back to view and then hide and show and turn on the dimension names, you can see the dimension showing up. So that is dimension 1 for that hole. Now I'm going to need to know some things about the thickness, and I can see here that the thickness value is also called D1, and I know for the shell function there was only one parameter, so this is going to be called D1 at shell 2. That's how that parameter is going to be called. Now I need to be able to do the same thing for the diameter of the holes, which is D1, but it's D1 at whatever sketch was used for that. So if I click on that part, you can see right up there that it's sketch 7 that's tied to cut extrude. That cut extrude. So that's going to be how I'm going to manage that when I write these equations. And so in this area, I'm going to start writing this special form D1 at sketch 7. That's the diameter of the hole. Then I'm going to say that it's equal to this global variable hole factor times D1 at shell 2. And doing that, then I will use those equations to link these parameters together. Now whenever the thickness of the part is changed, which is defined by the shell function, the holes will also change. Now why we would want that for this part is a different story, which we're not going to get into now, but the point here is just to show that you can link parameters through the equations features, through the equation tool. So now what I'm going to do is go in here and change the shell function to not have a 1 millimeter wall thickness but a 2 millimeter wall thickness, and I should end up here with holes that are 4 millimeters in diameter because the hole factor was 2, the thickness is 2 times 2 is 4, so that's where I'm getting the 4 millimeter diameter. Let's go and change this around now. I'm going to switch this to 0.5 millimeters for the thickness. So I should get small holes now, and I should have a thin wall. So a thin wall, I can see that, and I can see the small holes. I've linked these parameters together in that way. Now, although it might not be super meaningful for this particular part, there are parts that we would make in an engineering setting where we are going to want to link certain parameters together. And those equations are going to be a fantastic way for us to do that. I encourage you to spend a little bit of time trying to figure out for a part like this what kinds of relationships and equations would be meaningful, and then code some of them into your own part that you've created.